In this video, I'm going to review how to solve an equation that has decimals in it by using the process that we call clear the decimals. What I'm going to do is I'm going to scan each term and find the one that has the largest amount of decimals. So whenever I look at this, I see this term right here has 2 decimals. The rest of them only have 1. So 2 is my maximum amount of decimals that I need to clear out. So what we're going to do to clear those out is inside of every term, we're going to move the decimal twice. So when I think about 6.5, we're going to move it twice to the right, so I'm going to have one placeholder. I'm going to change that to 650 ends. Then in my second term, so I copy that symbol of addition, I've got to move it twice, so that's going to become 230 ends. And then that is equal to, I move this one twice, it becomes negative 1456. Copy the plus sign. And now move this one twice, and it becomes 620 ends. Now I just need to go ahead and solve this equation. So on the left-hand side, the 650 and 230 can be combined. So that gives me 880 ends on the left-hand side. On the right-hand side, the negative 1456 is a constant, and the 620 are variables, so those cannot be combined. Now I got to think, what side do I want my variables on? I want to go ahead and work with variables on the left, because if I play that would you rather game, I would rather have 880 instead of the 620. Okay, so if variables are on the left, I'm going to put my constants on the right. On the left, the 880 ends stay because they're variable. On the right, the negative 1456 stays. That's a constant, but I've got to cancel out those 620 ends. They don't belong on this side. Those are variables. So I do negative 620 because that's the opposite of positive 620 on both sides. Okay, now I'm ready to combine everything. 880 and negative 620 gives me a total of 260 ends. The negative 1456, I didn't have anything to combine with it. And then those canceled out. So now I've got it to where I have constants on one side and variables on the other, so I can divide by my coefficient of 260. So n would be equal to, it's negative 1456 over 260. That would reduce because I see that they're both even. However, all of your programs will accept the unreduced portion. Okay, there's one thing that I want to go ahead and talk to you about. Let's get a blank slate. Let's pretend like I had the equation 2n's plus 1.5 is equal to 2.36. Okay, I would scan it and I would realize that I have, let's see here, 0 decimals here, I have 1 there, and I have 2 there. So I would have to move all those decimals 2 places. But a common mistake that I see is right here when we said there were 0 decimals. You need to realize that is 2.0. X. So there is a decimal place there that I'm going to have to also move it twice. So whenever I do that, I realize I end up with 200 x's. Then I move this one twice, and I get plus 150. And then when I move this with that one twice, I get 236. And then I would proceed to solve that equation. So what I wanted to make sure that you remembered is watch out for when your coefficient or your constants are just whole numbers. You still have to move the decimals there.